right, now I'm going to do a quick refresher on factoring. And factoring goes a lot of different ways. There's a lot of different things we do to teach factoring. You can go onto YouTube right now and look into factoring of trinomials, and you'll get a lot of different videos. So if this doesn't feel, if you're not feeling 100% confident with factoring, there's a lot of other options you have. But we're going to go over just kind of a quick review of how do we factor. So when we first want to do is review how do we factor out a single monomial, a single term. So a monomial is like a term. And what you're looking for is you're looking for what each term can be divided by. So what each term can be divided by. So in this case, 3x squared minus 21. I'd say to myself, well, what can both the 3x squared and the 21 be divided by? And my answer would be, oh, they can both be divided by 3. So what you do in order to factor is it's merely rewriting it. Factoring is just rewriting the equation in a different way. That's what factoring is about. So I would write what I could divide out in front, and then actually kind of do that division here. So we'd have x squared minus 7. So this has been factored out. That 3 is what's factored out. All right. And then basically you have a statement here that if I did distributive property, I'd get back to where I'd start from. And that's what we want. We want to just show it in a different way here and say, okay, how does it look in different way other than without parentheses? So it's kind of like adding parentheses. So long we kind of emphasize, okay, get rid of parentheses. Now it's like, how can we add parentheses? So now we have difference of two squares, okay? You're going to be looking for something that has a square root, and we're going to subtract something else that has a square root. All right. Or if it has a square root, it's actually like something squared minus something else squared. All right, so you have a number squared and another number that's been squared. So the answer will always be the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So it's always going to be like x plus 4 times x minus 4 or x plus 7 times x minus 7, things like that. So in this case, I'd say to myself, well, the square root of x squared is x, and the square root of 81 is 9. Therefore, the answer to this one, when I factor it out, would be x plus 9 times x minus 9. Okay? Let me do that same process here. The square root of 4x squared is 2x. The square root of 49 is 7. So my answer would be 2x plus 7 times 2x minus 7. That is this answer factored. Okay, so that is our answer to what's the factoring of this 4x squared minus 49. So really what we're looking for is we're looking for a binomial, which means two terms. All right, and then something squared, something squared. So really kind of think about this. We're looking for binomial, two terms. We're looking for only having subtraction between them as well. So only having subtraction between them is going to be important as well. Alrighty, so factoring two binomials. In other words, you start with a trinomial, but you know in the answer you want it to be two binomials. Okay, so this is the one we want to remember from last year. There's a box that goes with these. There's a bunch of different things. I think the best way is to think of it as ax squared plus bx plus c, okay? And usually, if this is 1, and that's what we're talking about, you know, if the coefficient of your leading coefficient is 1, then you want to find two numbers that when you multiply them, you get c, and the same two numbers, when you add them, you get b. Okay, so we've done a bunch of problems like this before, where we said, okay, what's our numbers? Then when I add them, I get this, and I subtract, or I multiply them, I get this. I add them, I get this. So in this case, I'm saying to myself, what times what when I multiply them get 14, but yet when I add the two numbers, I get 9. So your choices are, well, 14 times 1 multiplies together to get 14, but I don't get 9 when I add them. What numbers do you get? Well, 2 and 7. This one works. 2 times 7 does equal 14. And notice how it's always your last value here. And 2 plus 7 does equal 9. So it adds to get the last term, or it multiplies to get the last term, excuse me, and adds to get the second term and the term in front of the x. So then your answer here would be x plus 2, x plus 7. That's the two binomials, two terms that we're talking about. So it's important just to remember this is where your values go, okay? So let's look here, okay? Now, in this case, what I'd be looking at is, what two numbers multiply to give me 12, but yet when I add them, I get a negative 7. 6 and 2 multiply to get me 12, but they don't add up to negative 7, so 6 and 2 don't work. Okay, I tried those. Those don't work. Sorry about the bell. Now let's try another one. Let's think 3 and 4. 3 and 4 add to get positive 7, but not negative 7. How can I make it a negative 7? Well, wait a minute. What if I had negative 3 and negative 4? I would still get a positive 12 here. I'd be okay there. And negative 3 plus negative 4 does equal that negative 7. So then that's where my negative 3 goes here, and my negative 4, I could have switched these. That would have been fine. This is my answer. This is my rewritten value for x squared minus 7x plus 12. Now, when we have a leading coefficient that isn't 1, and notice I said, okay, first we're saying what happens if you have 1. What happens if we have a leading coefficient that's not 1, like in this case where it's a 4? Well, there's a bunch of different things you could do. One is the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, hopefully you memorized that in Algebra 2. So that will always work. It'll always give you the right answer. I'm going to hit a more logical approach. I know that I'm going to have a binomial times a binomial. I know that whatever goes here, when I multiply it, I will get this 4x squared. I know that whatever goes here, when I multiply it, I get my 9. So let's start with what's in red, my 4x squared. What's two numbers that I multiply together to get a 4x squared? I'm going to go with 2x and 2x. And this is it's called guess and check is really what I'm looking at here. Now I'm going to look at what two numbers multiply to get 9. Well, the most common are 3 and 3. And then what you're checking here is the inside two multiplied together and the outside two multiplied together. So it's kind of like the IO type of thing, the OI, outside and inside. So you're going to say the outside here would be 6x. The inside actually would be 6x. What happens when you add them together? Do I get 12x? Yep, I get 12x. That's what I wanted. So this is actually my answer. Let me make it look a little pretty. So I really use a lot of logic there. The good news is we're not going to need it that much, all right? We're going to need it a little bit, but not a ton in this chapter. But it's good to kind of just have that reminder. And I'm looking at more the logical way. Quadratic formula will always work for this, okay? One more, let's look at this. All right, so what two numbers multiply to get 2x squared? I'm thinking 2x and x, all right? What two numbers multiply to give me 15? Well, there's 3 and 5. Well, let's look at my inside and outside. And this is where I might have to switch these two around. I might have to put the 5 here and the 3 here. I might have, let me try it that way first. All right, and then we'll see. So this is where we're checking our inside and our outside. Inside would be 3x. Outside would be 10x. 3x and 10x, is there a way to get this negative 1x? Nothing I can think of. So we know that's not going to work. So I think I'm going to go back to my first idea of switching them around. So I'm going to switch these two around. All right, that changes here. That changes these. So now my inside, there we go, I'm sorry, my inside would be 5x, my outside would be 6x. Hey, there's a way I can get a negative x. If this is a negative 6x and this is a positive 5x, so I want that to be positive and that to be negative. So in the end, my answer is this, 2x plus 5 and x minus 3. Okay, again, I know that's a little bit challenging. There won't be very many of those on in our work. So let's go through a few. The first one, I'm thinking they're both divisible by 2. Not only that, they're both divisible by an x as well. So I can factor out the single term of 2x. What I have left is x minus 5. Okay? Let's look here at 4. Let's look at 4 real quick. When I look at all of these, they're all divisible by a 3 and an x. So I factor out the 3x. What's left is x squared plus x plus 2. And then I can kind of say to myself, sorry about that, is there anything else that can be factored? In fact, there's not. 2 more. This is the difference of 2 squares for 7. So I'm looking at 7, I'm saying to myself, well, the square root of m squared is m. Square root of 64 is 8. It's just m minus 8, m plus 8. 9 is one where we say what two numbers multiply to get 14. Actually, we did this together, didn't we? And they add to equal 9. And if you remember right, the two numbers were 2 and 7. So we did that already. Here, we'd be saying what two numbers multiply to give me 70 and add to get me 19. I think it's like 5 and 20, would be 5 and 24. That's what it is. It's 5 and 24, I believe. And if, nope, that's not right. Has to be less than that. Darn it. I gave it a shot. Let me think here. I got to remember what equals 70. You know what? Let's do this. Let's see what numbers add to 70. So 2 and 35, 5 and 7. All right. So I'm thinking 70 is 2 and 35. Yep. 5 and 7. And so 10 and 7, or 14 and 5. That's it. 14 and 5. 14 plus 5 equals 7. So our answer here is x plus 14, x plus 5. It took me a minute, but we got that one. The answer here, x plus 2, x plus 7. Good luck with you.